So now we're going to learn about covariance and the correlation coefficient. And these are measures, numerical measures of association between two variables. And association means, do they influence each other? So if we spend more on marketing, do sales also go up? That would be considered a positive relationship. The more we spend on marketing, the more sales go up. Negative relationship would be like the more somebody smokes cigarettes, the shorter their life, right? It decreases their life. It doesn't increase their life, it decreases their life. So that would be a negative relationship. There'd be a negative relationship between smoking cigarettes and life expectancy. There's a positive relationship between spending money on marketing and sales going up. So that's what we're going to see. We're going to learn about covariance and the correlation coefficient. You can pause this video and read that slide. And you can pause the video and you can read the slide where we talk about positive values indicate a positive relationship, spend more on marketing, and you have more sales. Negative values indicate a negative relationship, smoke more cigarettes, life expectancy goes down, negative relationship. And so here's how you calculate the covariance for a sample and for a population. And on our notes, here on the notation of like, what are the different symbols for sample versus population? I have covariance is S, X, Y, and covariance here is sigma, X, Y, and correlation coefficient is this, and it's that for sample and population. And I'm actually not sure what you call this. I think it's rho. I don't know what that P is. So we could come in here for the correlation coefficient. And when we get to that, we'll go to ChatGPT and we'll ask what those symbols are. Well, it's right here, actually. That's where we just were. Is that where we were? Correlation? No, we were at covariance, so right here. So this is the one. So let's get these symbols right here. I'm going to just, show you how I use ChatGPT. And I don't know what those are called, so let's find that out together. So I'm going to go to the snipping tool. And actually, I could just do this. I could go File, Download, and I could download this JPEG image, the current slide. So I'm going to download that. And that came down as copy. It's copy of, and I'll go to ChatGPT and I'll create a new chat and I'll come over to my downloads, which will be in here, and I'll find that copy of, which is right here, and I'll drag that and drop it. And can you please explain the Greek, explain the info on this slide and also the Greek letters? What are they called? There we go. So we'll let that run for a second. I guess here it is. We'll just do it now. The slide you've shared explains how to compute the correlation coefficient, a statistical measure that describes the strength and direction of a relationship between two variables. Correlation coefficient is a sample. For a sample is denoted as RXY. The formula is this. Here, SXY is the sample covariance between variables at X and Y. SX is standard deviation, and Y. But I want to know what that R is. All right, so I could bring that, see if I could copy that. What is this symbol? What is this symbol? Symbol in Greek. Yeah, so it kind of got it there. Maybe we'll do that. And for a population, the correlation coefficient is denoted as PXY, the Greek letter rho. So this is rho. And we didn't get this one here, what that was. And so then it explains it. There's rho, there's sigma. So it's explaining sigma. And then RXY is used for sample data. And so now we'll ask it this. So we have rho. And R is not Greek letters, a Latin letter. Okay, R is commonly. So it's just the letter R. So we have P is rho. And this is just R. Interesting. All right, so here we have that notation. We have R and we have rho for the correlation coefficient. And for covariance, we have SX and sigma XY. We have SXY and sigma XY right there. And then also on our formulas, we have this one right here where I have the covariance formula and also the correlation coefficient. So S, sigma, R, and rho right there is how we do those. So let's see again the presentation, what's going on with that. And so here in the correlation coefficient, we were talking about covariance first. And with covariance, we went over positive relationships and negative relationships. And then here's the formula for computing covariance. So the difference between a data point and the mean. and then the difference between the other, for the other data value, the data point and the mean, and divide by n minus 1. Once that's all summed up, multiply these together, sum them up, divide by n minus 1. And here's how you do it for a population, very similar, but no n minus 1. And then we have the correlation coefficient. Correlation is a measure of linear association, not necessarily causation. Just because two variables are highly correlated does not mean that one variable is the cause of the other, right? So correlation is not causation. Just because every time it rains there are clouds, that does not mean that when there are clouds it's going to rain. Sometimes there's just clouds. So the correlation between rain and clouds does not mean that clouds cause rain, right? Like clouds can be there without rain. Correlation is not causation. It's kind of an interesting phrase. So correlation coefficient is computed as follows. So we get here the covariance up top. So remember, covariance is SXY or sigma XY, SXY or sigma XY. And then we have the standard deviation, SX. We have standard deviation for X, standard deviation for Y. And remember, standard deviation is S, or S for a sample, or sigma for a population. Here it is, standard deviation for the population X, standard deviation for the population Y. And then covariance, here's the covariance. So correlation coefficient is covariance divided by the product of the standard deviations of each X and Y, each of the variables. That's correlation coefficient. And that kind of brings it all down to a scale between -1 and 1, as opposed to covariance. Could be other numbers. Correlation coefficient is always between -1 and 1. And -1 means a negative linear relationship, and +1 is a strong positive linear relationship. And 0 means, weaker. The closer the correlation is 0, the weaker the relationship. So here's an example, San Francisco electronics store, and here's the data, week number 1, 2, 3, 4 through 10, the number of commercials they ran, and then the sales they got. And then when we find that, we have here, it'd be nice if we could see this on 2 slides. This is what I'm going to do. I'm going to go like this and open it in another one, and then I'll bring this over, and I could do that, and I could bring this one over here like that. And so there's our data, and then with our data there, we could see here, and it's a little bit smaller, but you can still see it. We have X and Y, 2 and 50, so 2 commercials and 50 sales, 2 commercials, 50 sales. We have 5 and 57, 5 commercials, 57 sales. And then we do the difference between that data point and the mean. So 2, there's the total, there's 30, so the mean is 3. If the total is 30 and we have 10 weeks here, the mean is going to be 3. So the difference between 2 and 3 is -1. 2 minus 3 is -1. 5 minus 3 is 2. 1 minus 3 is -2. So here's that data point minus the mean. And then we do the same over here with this data point minus this mean. So the mean here would be 51. So 50 minus 51 is -1. 57 minus 51 is 6. And then we multiply each of those together. -1 times -1 is 1. 2 times 6 is 12. We add all that up, we get 99. So that's the top part, 99. Then we do n minus 1. 10 minus 1 is 9, and 99 divided by 9 is 11. So our covariance is 11. And then to get our correlation coefficient is going to be, I'll leave the data here. Maybe we want to see this one now, right? See that one now there, and we'll do correlation coefficient. So the sample covariance is 11. Correlation coefficient, we get the standard deviations of each of these, multiply them together, and we get a correlation coefficient of 0.93. So anything -1 to 1, +1 is a really strong correlation between the data. As one goes up, the other goes up. So as we spend more on marketing, we get more sales. And so that's what that's showing us there. And so that's, that's easy to interpret, as opposed to 11, just like the closer we are to 1, the stronger they are correlated, the correlation coefficient. So here's how you would, and I'm just going to get rid of this one now. Here's how you would calculate that in Excel, just FYI. You could pause the video and take a look at it. And then the last part of this chapter just talks about adding numeric measures to a dashboard. So you could pause the video, you could read that, and you can pause the video and see the numeric measures here as descriptive statistics added to a dashboard. This was a big chapter. It was a big chapter. it was a big chapter, and there's some really important information in there, and I really wanted to make sure that I took care to make these videos well, so hopefully they helped you. And do your assignment so that you could reinforce everything that we're learning in this chapter, because some of this stuff will be used throughout the rest of the semester. See you next time.